All right, now we're going to estimate the sums and differences of mixed numbers. So we're adding and subtracting, but instead of with single fractions, we're going to be using mixed numbers, which are a combination of whole numbers and fractions. And again, we'll be using those benchmarks 0, 1/2, and a whole to help us out, what we did in the first lesson. Alex has 5 cups of strawberries. He wants to use 1 3/4 of cups of strawberries for a fruit salad and 3 1/2 for jam. Does he have enough strawberries to make both recipes? So let's see, what do we have to figure out here? So we can use estimation. So what does he, if he's going to, whoops, get that up there. If he needs 1 3/4 for fruit salad and 3 1/2 for jam, we usually would round 1 3/4 up to 2, and 3 1/2 we would round to 4, and you would need 6 cups, but those were both over estimates. So I would say if he has 5 cups, does he have enough? So let's see. You can also figure this one out because this one's pretty easy by using exact. If I say 1 plus 3 equals the whole number 4, and I only have 5 cups, now you have to figure out, would 3/4 and 1/2, if you added them together, would they be more than a cup? And 3/4 and 1/2, if you know your benchmark fractions, you know that 3/4 is bigger than a half. So yes, this would be more than 1 cup. So no, he doesn't have enough. Well, that's what we'll be doing today. We'll be estimating and mixed numbers. So in our video today, Jamila's mom wants to make a size 10 dress and jacket. About how many yards of fabric does she need? This is a lot harder than the preview question. So she wants to make a size 10 dress. So the information that's important to us is right here. Size 14 is extra information. So if she has 10, about how many yards of fabric does she need? So we have 2 1/4 plus 1 5/8. And we're going to do some estimating. So let's see how we figure that out. Your 2 ways you can do it. You can use your number line, and you can also use your benchmarks. So let me rewrite it again because I got rid of it for you. 2 1/4 plus 1 5/8. So if you go with your whole numbers to start, you know you've got 2 plus 1 equals 3. So now we're going to figure out 1/4 plus 5/8. So you can go back to your benchmarking there and decide that 1/4 is going to round down to 0. 5/8 is going to round to 1/2. So we would say this rounds to about 3 1/2. And that's one way you can do it. If you look at the number line here, 2 1/4 plus 1 5/8, 1 5/8, 1 5/8. Is it closer to 1 or closer to 2? It's closer to 2. And 2 1/4, is it closer to 2 or closer to 3? It's closer to 2. So we say 2 plus 2 is 4. So we're saying she needs about 4 yards. That's one way, using the benchmarks of 0, a half, and a whole on a number line. Or you can replace to the nearest half unit. And again, that's using the 0, 1/2, and 1 whole method. So either way, like when I did it over here, I got 3 1/2. When you round, because when you're rounding, you could get 4 yards. When you round in this model here, they're getting 4 yards, but any of those would be fine. They're all close. Oops. Got too many things going on here. All right. So let's do a little practical work. To estimate with mixed numbers, when should you round to the next greater whole number? So when you see a mixed number, you always want to round up when you're at, it's kind of like, our rounding rule is 5 or more, blah, blah, blah. Well, 1/2 is equal to 0.5. So anytime it's 1/2 or more, so it's half or more, you're going to round up. If it's less than 1/2, you're going to round down. When should you estimate a sum or difference? When you see the word about in your word problem, or when you infer that an exact number is not needed. So round to the nearest whole number. 3/4. And remember, if you're using the number line model, you divide it into fourths because the denominator is telling me to divide it into fourths. 3/4 is way over here. Is it closer to 0, 1/2, or a whole? And for our rule for rounding, if it's 5 or more, we round up. So 3/4 will actually round up to a whole, not down to 1/2. 1 5/7, again, if you want to use a number line. You take sevenths because the denominator is saying sevenths. So we're going to decide, is our 5/7 going to bump up that 1 5/7? 1, 2, 3, 4, 5. That's going to bump up. So 1 5/7 is greater than 1 1/2, so that's going to bump up to a 2. 2 3/10. Looking at the 3/10, you're deciding between 2 or 3. Where's it going to go? Are we going to go down to 2 or up to 3? 3/10 is less than 1/2, so we're going to go down to 2. Now in 6 and 7, we're doing some additional computation, adding or subtracting after we do our rounding. So we're going to estimate first. 2 5/9. 5/9 is bigger than 1/2. 1/2 would be like 4.5, so it's a little bit bigger. So we have 3. And anytime you see that unit fraction, remember, if it's a unit fraction, it rounds down. The 3 minus 1 equals 2. 2 4/10. Tenths, the halfway point would be 5/10. So 4/10 is less than 1/2. That will round down. 3 5/8. For eighths, the halfway point would be 4/8, and 5/8 is bigger. That's going to round up. So 2 plus 4 equals 6. Oops. Wait a minute here. What am I doing? Yep. Okey-doke. And those are rounding, so you want to be close to that. You don't have to always be exact. So here we are on a number line here. Use the number line to round the mixed numbers to the nearest whole number. So they plopped all the numbers on the number line. Notice their number line starts at 11 and ends at 12 because all of our values are 11 and then a fraction. So 4/6 is, if you remember from the fraction game, what is 4/6 equal to? If you 4/6 in lowest terms is going to be 2/3. So that would be right there. So that looks closer to 12. 11 2/8. 2/8 is the same as 1/4. And I'm doing that quickly because I know even number, both will divide by 2. Even number, both can divide by 2. So I know this one's going to go down. 8/12. I can do the even number thing. It's going to take me a little bit because I got to do it again. Or when I was at that 8/12, I could reduce this fraction by finding a factor, the greatest factor in 8 and the greatest factor in 12. 1 times 8, 2 times 4, 1 times 12, 2 times 6, 3 times 4. The most common, greatest common factor is 4. So if I divide it by 4/4 right away, I will get 2/3. Quicker than doing all this wiggly stuff. So 11 and 8/12, and you don't even have to really do all that. If you know that 6/12 is the halfway point, 8/12 is bigger than that, so I'm going to round that up. For tenths, the halfway point is 5/10, and this is 4/10, so that's less than that. So I'm going to round down. There you go.